Welcome to Technology and Computer Science with Felix Pham from Vietnam. Today I want to start on a video series for an automated Binance trader using Python. We will start in this episode with listening to trades that are happening on the exchange. In later episodes we will have a look at creating alerts that will send you notifications to either Slack or Telegram or other messaging services where we can find an API for. And in the last part of this series we will look at actually trading on the signals we see in the market data.
Okay, we want to start with the passive listener first. The listener will connect to the Binance API and will listen for price updates. It doesn't require any login data, so we don't need any API key for passive listening of market prices. And also we can start creating the logic for our trading algorithm first. Binance has a very well-documented API. The best way to listen to market data updates continuously is by using the WebSocket API. Clients can subscribe to topics, and Binance will continuously send out events concerning those topics to its subscribers. In order to access WebSockets in Python, we can make use of already existing libraries, but these libraries are usually not installed by default, so we have to make sure we have the proper requirements installed. I already created a requirements file where I listed the two dependencies that I think we will need. WebSocket client will be the library used for WebSocket access, and the requests library is a very popular library that we can use for the request reply type REST APIs, which we don't use in this episode, but we will use later. So you can now install those dependencies with pip3 install -r, then provide the requirements txt, and because I don't want to use root access or administrative access, I use the --user flag here. Okay, I've already installed those, so for that reason there's nothing to install anymore. It might take a few seconds or a minute for you to install those requirements. So for the overall construct of our bot, our trading bot, I don't want to care about what underlying technology, what underlying protocols of communication are used with the exchange. So for that reason, I will write a wrapper class that will abstract away the whole WebSocket protocol part. I call this class listener. And of course, we need some specific initialization here. So for now, I just say, okay, this is our class. And of course, I will need some kind of WebSocket connection. So I definitely need to import the WebSocket API. We will initialize the socket first. And that will be WebSocket WebSocket API, WebSocket app. And this WebSocket app will get some URL. So we go back to our definition of our API, and we copy this base URL. And we say, okay, our URL equals this base URL. And we also need to give it some stream name. So we don't care for those combined streams for now. So we will just say, okay, we create a raw stream. So we need to attach a ending WebSocket and give it a name. So WS and from listener. We just call it listener. Okay, and then we can actually provide some callbacks that will be called when the WebSocket communicates with the server on the other side. So we can provide an onOpen callback, and we will define an onOpen method for this. And we can have an on, we get a normal message in. And we can also provide callbacks for onError and for onClose. We should provide an onError method, but I think that would probably will not have the time to actually deal with error messages. So I might add that later, but I don't think I have the time in this tutorial to properly handle errors. Okay, and of course we need to define those methods. onOpen, you now have to actually look at the definition of the WebSocket API, and then you can see here that the onOpen function, they expect one argument, and this would only be the WebSocket itself. I mean, the self is because it's a method of this class, so the WebSocket is the actual argument they're talking about. And I will do something here, and we will also have a def on message, and we will do something here. But the on message, of course, also gets a message object. First argument is a class again, and the second argument is the UTF-8 data that we get from the server. We already initialized the socket in the init method, but we didn't actually connect the socket. So we need to also provide some kind of method to connect. And I will call this method run. This has, I explain later why. But basically, it doesn't get any parameter, it just says run. And then we use the useful run forever callback here, which basically is a blocking call. So if you call the run method, then this method will not return because it will run forever. So we definitely need to deal with that at a later point, but here this run method only calls run forever. Okay, let's write a little test, or let's test our code so far. I put this name equals main guard here. This means that this code is only executed if this is the main module. So if some other module just loads this module, this part will be ignored. So this is a place where we could put some tests, some debug code. But yeah, we should clean that up later. But for now, we can do it to easily have an overview of everything we do. Okay, so what do we actually want to test? Okay, we have a listener that we need to create. And then, yeah, we need to run, which we know will run forever. So this would be a first test. And in order to actually see something, we might put a print method here first to just print that it's open. And let's test that code. And see what happens. Ah, yeah, okay. So it's open now, and it runs forever. And we do get updates from the server, but because we didn't tell the server what we actually want to listen to, we will not see anything here. So okay. So what can we do next? Well, first of all, we need to consider how we want to actually interact with this listener. So we cannot just have our code block, because then we cannot do anything specific. So we could, of course, we can write code in here. We can say, hey, if I receive a message, I want to do something, but that would not be good, because that would actually block the socket. Not the socket, but the part of the program that is watching over the socket. So the part of the program that sees, oh, there's new data on the socket, will then also execute whatever is happening here and here. And if we spend a lot of time in there, then the part that is supposed to watch over the socket cannot do so, and we will basically we might have our socket overrun. We might lose data because of that. So instead, we need to instead of the watcher executing a lot of code, the watcher should just tell someone else to execute the code. And we do that by using threads. Okay, threading. So this is basically a second actor in our application. So we don't want to call run directly. Instead, we want to have a thread, a second actor, and that is threading.thread. And the target is our listener.run. And also, just in case, because we are skipping a lot of error handling and other proper handling, to make sure that if our main thread actually closes, I don't want the watcher thread in the background to continue listening to the socket. So I set this thread to be a daemon thread. So when our main thread dies, it takes this one with it. Okay, and now we could basically just say we want to start our thread. And yeah, we cannot leave it at that, because as I just said, if we now use a different worker to actually watch, and our main worker, our main thread would end here. And when our main thread ends, our program closes, and when our program closes, it takes the other thread with it, so we wouldn't actually see anything. So we need to somehow keep our program alive for a little bit longer. And to just check it out, I will sleep for 3 seconds here. And of course I need to import the time library for that. And let's check it out. It should actually be the same as before, only that after 3 seconds it should die on its own. That felt a little bit faster than 3 seconds, to be honest. But could be 3 seconds. Okay. Now, I already said we want the actual message, the "oh, I'm open" or "oh, I really got a message." I don't want to handle that here. Instead, I want to give this message to someone else. And this is not the easiest thing to do when we deal with multiple threads. But thankfully, Python already provides us with a library that makes it actually easy for us. And all the complex part are hidden. And this is by using the queue library. So we create a queue, and the queue on its own is already thread safe. So we tell our listener he now should get a queue object. We don't want to call it queue because that would override the module. So we call it message queue. And we say that we store that in the instance. Hooray. And then we can say, okay, instead of printing it here, we say self.message queue put, and we put the message in here. And basically we would do the same here, but with the actual message that we got. And now we need to externally create that queue. Oh, not overwrite the module. Q is q.q, and we provide this here as well. Message q equals message q. Okay, what can we do with that? Well, we can say, instead of just sleeping for 3 seconds, we can say, okay, we wait for the message queue to actually retrieve something. And this would actually be blocking as well. So here we would basically have to know, oh yeah, we do expect something. So we can basically, for now, we can just say, okay, while true, message equals message queue get, print message. Okay, for the queue, because it's can be used in a multi-thread environment, and we are using it in a multi-thread environment. There are situations where you might want to know if the actual consumer of the message is done with processing the message. So for that reason, there's actually a task done method, which is basically just counting, okay, I took one of the tasks I took out is done. So basically the provider of the message queue can see if the queue is not just empty, but everything has been processed as well, which can be used to properly close down a program. So it's a good thing to just put the task done there as well, especially since we are done with our task, we printed the message. Okay, let's test it. This should again be completely blocking. We got our it's open message. And now we are basically waiting in an endless loop on the queue. But we are not just looping right now, we are really in the message queue.get method. So this is a blocking method. Okay, let's interrupt that. And we see here already this doesn't really look nice. I mean, at some point we want our bot to run forever until we tell it to stop. So, and we usually stop it with a keyboard interrupt, but then this is an expected behavior and should not result in a message like that. So we can actually already put this whole thing into a try except block. I mean, we don't have to make it nice here because this is just our test environment. And yeah, we just want to pass that. And then at the end, we want to basically say, okay, we somehow want our thread to stop the endless loop on the socket. And we do that by calling close on the socket, which at the moment we cannot access, but listener.close. So we need to provide that. And because we're running a thread and our actual target of the thread should now be stopped or should be in the process of stopping, we can now join our thread and wait until the thread is actually done. And after that, we can, we just leave our main thread to die a natural cause, to die a natural death, and everything should be cleaned up. And here we have it. We have a nicer handling of everything. Let's start subscribing to a topic that the exchange provides. And aggregate trade. One topic the exchange provides, and I want to actually subscribe to aggregate trades. And I do that by, aggregate trade. I even have an example here that we can use. List subscriptions, unsubscribe, subscribe. Here, subscribe to a stream. We need to send this type of data. Okay, let's do that. So I want to create an abstraction of the subscription part. So I only want to provide the ticker here. I don't care about making sure that we don't do multiple subscriptions. I think Binance already takes care of that anyway. We don't provide an unsubscribe, although that would be very similar to this one. And now we basically want to send something over the socket. And we need to send it as a UTF-8. And basically they expect UTF-8 JSON data. So we basically just use the JSON module, which is already provided by Python. And we want to dump, I mean, yeah, we could just construct the string, but I think it's nicer to actually have the proper, to have everything here in object form. Okay. We only want to have aggregate trade. We don't care for depth data for now. I use the new F strings and say here I want to add the ticker. I also don't care if someone, provides a wrong ticker. I don't check that here. That would be something that you could add as well. Okay, and one more closing one. Oops. So what do we need to consider here? So first of all, I use the JSON method, so I need to import the JSON module. And then let's have a quick look at how we need to provide the data to Binance. So first they want to know what we want to do. So there's a subscribe, there's an unsubscribe, there is a listen as well, a list as well, where you can actually list what you're all listening to. And then your actual parameters based on what you want to do. So for a subscription, you need to provide the subscription label and an ID. And the ID is used because you might provide a wrong ticker, or you might provide a wrong topic, and Binance would love to tell you that something went wrong. But the thing is that this is not a request reply type protocol. So you send data out, and at some point you might get answers, or you might get answers for questions that you didn't ask. So when you subscribe, you will get a lot of answers for aggregate trades over the whenever a trade happens. So even if you don't specifically ask what kind of trade just happened, you will get an answer. So they need a way. You need a way to actually associate the answer you get to the request that you sent. So for that reason, you should provide a unique ID here. And it's easiest to just have an incrementing counter here. Although I have to say there's of course some caveat here. And the caveat being that because we are multi-threaded and we probably, that's the intention of the way I'm implementing this, we call this method from an external thread. And we don't know if there will only be one thread or if there will be multiple threads who interact with this listener. It's possible that there might be a race condition. There's definitely the potential for a race condition here, that because I need to increment the ID as well as read it out. So if there happens to be some interrupt at that point, it could be that we have some unintended behavior. So for example, two of our requests using the same ID. I don't really care for that right now, because for now I don't see why we need multiple threads who access this listener, and also because we probably set up our subscriptions at the beginning when we start the program, and even if we have multiple threads, they are just acting on the data that comes in. So I'm not planning on constantly changing the subscriptions here. But you need to be aware that this instance is written with this restriction in mind. And of course, we could use some primitives to guard ourselves. We could make sure that this is an atomic operation. But as I said, this would complicate our example and doesn't really provide any benefits, considering that I know how I want to use this instance. Okay, message ID. Now that we have a way to subscribe, we all actually need to do that, right? So let's put that in here. We already started our thread, so we might actually not put that in here. So we can, of course, only subscribe once our connection has been opened. And our connection doesn't open instantaneously when we start the thread. We saw that on the right side when the it's open message took some time to actually arrive. So assuming that we definitely managed to open the connection, we can say, okay, the first message that we get will be our open message. And once we got that message, we can say, okay, now listener Okay, we just saw that something went wrong. I need to have a look at the, didn't I call it socket? Ah yeah, save.socket.socket. Now, of course, we want to send something over the socket. Oops. Let's check it out. And we get data in. So we can check if our control C still works. And what do we get? Okay. We get a type here, like what kind of event do we see here? We see an aggregate trade and some kind of timestamp. All those keys are, of course, explained on the WebSocket API documentation of Binance. But yeah, we have the symbol, our ADA USDT here, and we should have some kind of price in here as well. Yeah, that should be the price, P price, Q quantity, I guess. Here we can actually see what kind of payload we have to expect. So we already saw the E is the event type, aggregate trade. We get some timestamp symbol, the price, the quantity, everything that we need to actually work with. We are actually nearly done already. There's one thing I like to do though. Maybe we want to differentiate between our onOpen and our onMessage here. We can do that by actually assigning labels to our messages. I will call this message type and make this an enum, which I of course have to import. And then I say we have onOpen messages and we have normal messages. And then basically whenever we put something in, we just say, okay, this is the Probably we are too long for one line here. Message type on open and our message. Basically now this on open doesn't tell us anything, so I could just as well say none. And in the other case, we get a on message and our message. Of course, I want this opening bracket here. One more thing that we can do, we can actually already cast the message. One thing that we didn't see in our printout here, but should be obvious because we sent UTF-8 data to the exchange. Of course, we get some UTF-8 data back. We actually need to parse it. So we can already, assuming that Binance always returns us with structured data, we can say message equals json.load string from message. Then we already have structured data in our output. And then we can actually, we could leave it like this, but just to show how we could use the type, we can say, okay, we just get something, which is now, of course, the message type and message. And if message type equals on open, then we want to actually subscribe. And otherwise, we just print the message. No, we always print the message, which will be none. So in the case of the on open. On open, yeah. Of course, on open is not defined. It's message type dot on open. Okay, we are open. So we should now be subscribing to trades. Which we don't receive for some. Should work. Message type dot.
Twenty minutes later.
Okay, I already found out what's the problem, and this is a good example why the developers of the WebSocket API, they tell us to enable tracing while we are developing. Enable trace true, which will not look pretty, but it would basically tell us if there's a problem on our side. Yeah. And we already see when we have trace active, we made the same mistake as we did before. We forgot that this one, of course, needs to be properly addressed. Okay, and now we should hopefully, so I'm a little bit optimistic here, and we should now see our prices coming in. Yeah, that looks much better. Okay, so from time to time we might have to enable that to debug. Okay, this has been the first episode of our tutorial how to write a Binance auto trader bot. And this tutorial, we basically created a wrapper class that already abstracts the whole WebSocket API away from the upper layers of our program. Thank you a lot for listening, and stay tuned for our next episode.
Thank you for watching this first episode. I hope you enjoyed it and are looking forward to upcoming episodes. If you are a holder of the utility token ADA, you can support my efforts by staking with my staking pool Felix Farm, ticker LIX. Don't forget to hit the like button and subscribe.